So welcome back 9th class students in our chemistry class, and the chapter is same, chemical changes in chemical reaction, the second chapter, and we are in our 6th lecture. Now two topics are left in this. The first one is displacement reaction and the other is double decomposition reaction. So those are very simple ones and you have studied in 8th class also. So we will start first today displacement reaction. What is a displacement reaction? Displacement reaction. So for studying displacement reaction, as we have taken the help of activity series in decomposition reaction, in displacement reaction also the activity or the reactivity series plays an important role, or you can say the displacement reaction entirely depends on the activity or the reactivity series. Now in this we will see the activity series for metals also and for non-metals also in the decreasing order of the reactivity. Metals starting from potassium, sodium, calcium, then we have magnesium, aluminum, zinc, iron and so on, and this is the reactivity series in the decreasing order of metals. And in non-metals, the fluorine is at the top, the most electronegative or the most reactive non-metal, then fluorine, chlorine, bromine, iodine. This way it goes. Now what is the concept? The metals, in both in metals and in non-metals, the one which are placed above or the one which is at a higher level, it replaces or displaces the one which is at a lower level from its salt solution or aqueous solution. Means the more electropositive in case of metals, what is the meaning of electropositive? It readily forms cations by losing electrons. And what are non-metals? More electronegative non-metals which readily accept anions, electron to form anions. So with the help of reactivity series, the more electropositive displaces less electropositive. Similarly in case of metals. Similarly in case of non-metals, more electronegative displaces less electronegative. So dear students, now I will go to the chart and then we will have some examples for displacement reactions. So displacement reactions or replacement reactions. Now before going to the activity or the reactivity series, now let us have the symbolic representation in terms of A and B. Suppose we have AB in its salt or aqueous solution and there is a C. Now C can be metal as well as non-metal. So what it will be? If suppose, so we can have two types of representation. AB plus C gives, this will CB plus A. So C is acting here as a, C is replacing A. So C, what is C? So just understand this. C is acting here as a cation, that is metal. Now if this reaction goes like this, AB plus C, it gives, now we have AC plus B. B is being displaced. So how? What is C acting here as? C is taking the place of B, means C is acting here as non-metal, and B is, so we have two types of representation in the case of displacement or the replacement reaction. Now let us see this reactivity or the activity series. Now in the reactivity of the activity series, it's also in your book. What I have done is that metals and then we have, I have shown non-metals. So this is the reactivity series for metals. The one which are present above, they will displace the one which are at a lower position, and reactivity decreases on going from top to bottom. So one means, or you can say in the terms of chemistry, the more electropositive displaces the more electropositive displaces the less electropositive. The more electronegative displaces the less electronegative. And if you remember, we have hydrogen. So above hydrogen, the metals can displace hydrogen also, and you have studied this in 8th class in the formation of hydrogen. If you see that elements which are present above hydrogen, they can displace hydrogen from the mineral acids to form hydrogen gas and the respective salts. Now let us go for some examples. 3 or 4 examples I will, and it's a very simple one, so I hope you have understood it. So now let us take some example of displacement reaction, and all the reactions are given in your book. I have taken from your book only. Zinc plus copper sulfate gives zinc sulfate plus copper. So what we are getting? Copper being displaced by whom? By zinc. Why zinc is displacing copper sulfate from a salt or aqueous solution? Because in the reactivity series, zinc is above copper, so it has a tendency to, so zinc takes place here and zinc sulfate. Why zinc sulfate is being found? Because if you want to see the mechanism, Cu is +2 and SO4 sulfate 2 minus, and zinc has also +2 valency, so it displaces, and +2, that's why the formula is zinc sulfate. So this way you can check, and plus copper you are getting. Now this was the case of a reactivity series of metal, means a more electropositive metal is displacing a less electropositive metal. Now the second example of electronegative, a more electronegative displaces a lesser electronegative. Chlorine. So we have at the top fluorine, chlorine, bromine, and now KBr. Potassium bromide here is in its aqueous salt solution, so it is being displaced by this. And again, considering the valency, that Cl has -1 valency, K has +1 valency, this KCl is being formed. And why, dear students, Br2 is in the form of molecules? So for your knowledge, I am telling you that these halogens, fluorine, chlorine, bromine, iodine, they are so reactive, including oxygen. Oxygen is not a halogen, that they don't exist in their atom form, as like potassium, as like sodium, as like magnesium. They immediately react with the other atom, with the other similar atom, and they form a molecule. They are so reactive. That's why you are seeing here chlorine, Cl2, Br2. So that's the information I was trying to share with you, and I have shared with you. So keep it in mind. Being so reactive that though they do not exist in the single atom form, they exist in the molecular form. Who? Bromine, chlorine, iodine, oxygen, all these reactive non-metals. They form covalent bonds, in fact. Now the third is aluminium, then copper sulfate. So see why this reaction is important, because whatever aluminum is more reactive, why it is above the copper in the reactivity series, and it is displacing, it is taking the place of copper here, aluminium. And how this formula is written? This formula is written by considering the valency of aluminium +3, and we have sulfate SO4 2 minus. Again, that exchange of radicals will take place, exchange of this charges will take place, and Al2CO4 whole thrice is being formed. You have seen this, and you have practiced this a lot in 8th and in 9th both, and Cu is being displayed. Now this was the reaction I was telling about in the formation of hydrogen gas. Magnesium, an element, plus HCl. Now what is being and who is being displaced? So hydrogen is being displaced here, my dear students, because in the activity series magnesium is above hydrogen. So hydrogen जो है H plus and Cl minus के फॉर्म में यहाँ पे है, H plus and Cl1 minus. तो मैग्नीशियम क्या होता है कि it takes the place here. H को डिस्प्लेस कर दिया तो H again being it will form H2 being reactive तो MgCl2 because Mg की वैलेंसी क्या होती है मैग्नीशियम की +2 तो ये इसके साथ रिएक्ट करा गया MgCl2 बना दिया और H2. So in this way you can say it is used in the formation of salts also and in the use of the formation of hydrogen also. Now this was all about the displacement reaction. So next we have to study about double decomposition reactions. It is also known as double displacement or double displacement reaction. So what is the process or what is the concept in double decomposition reaction? The first is simple one that both the reactants, we have two reactants here and both the reactants are decomposed to form new products. Both the reactants are decomposed to form new products. And the second one is कि we have aqueous salt solutions A, B and CD suppose. And what happens? There is exchange of radicals. Exchange of radicals take place to form new products. So both the concepts are there. Either they are decomposed, both the reactants, suppose we have AB plus CD. So both the reactants are decomposed, दोनों टूटेंगे. It is in the form of A plus and B minus. And it is in the form of C plus and B minus. So what new substances will be formed? ये किससे जुड़ गया? A plus और D minus, तो AD बन गया. Plus बचा क्या? C plus तो पहले हम कैटायन लिखेंगे ना, देखो कैसे फॉर्मूला C और B. तो दिस इज द डबल डिकम्पोजिशन रिएक्शन. इसीलिए दो बार डिकम्पोज हुआ, दो रिएक्टेंट ये भी डिकम्पोज हुआ AB, तो AB से AD बन गया और CD से CB बन गया. और यू कैन से देयर इज एक्सचेंज ऑफ रेडिकल्स A आपस में. So now this double decomposition reaction is, dear students, it is of two types. This double decomposition reaction, all of you must be knowing, it is of two types. One is the precipitation reaction. Precipitation reaction. And the other is the neutralization reaction. And the other is the neutralization reaction. Now, one by one we will study the precipitation reaction and the neutralization reaction. To give an overview, what is the neutralization reaction? In neutralization reaction, what happens? The same thing is happening there also, means both the reactants are being decomposed or both the reactants in their aqueous or salt solution, they exchange their radicals here also. But the reactants, what in the case of neutralization reaction, what are the reactants? They are acid and base. जो डिकम्पोज हो रहे हैं वो दोनों रिएक्टेंट वो क्या है? वो एसिड और बेस है. सो दे रिएक्ट टू गिव सॉल्ट एंड वाटर. तो इट कम्स अंडर द हेडिंग ऑफ न्यूट्रलाइजेशन रिएक्शन. और प्रेसिपिटेशन रिएक्शन में क्या है कि बेसिकली हम जो एक्वस सॉल्ट सोल्यूशन लेते हैं, एक लिया फिर दूसरा लिया, तो एक हैवी मेटल्स का होता है. तो हैवी मेटल्स क्या होते हैं? वो बीइंग हैवी दे प्रेसिपिटेट. द कॉन्सेप्ट ये है. तो वो एक बाय एक्सचेंजिंग द रेडिकल्स एक प्रेसिपिटेट के फॉर्म में आएगा और दूसरा एक और आएगा. सो दिस इज द कॉन्सेप्ट ऑफ प्रेसिपिटेशन रिएक्शन एंड neutralization reaction. Now in the next session I will give you in detail what is an acid, what is a base, and how the neutralization reactions takes place, and examples of precipitation reaction. So in the next session I hope that we will try to finish it, or it can take one more lecture. So for today, dear student, that's all for today, and I hope that you must have done all the numerical part of the chapter 1. Do it, very important. So don't miss the numericals, and I have explained you each and everything. So that's all for today. Thank you very much.